Hello everyone. Today our topic is quick sort algorithm. What is sorting? The process of arranging the data elements or array elements in a particular order, basically in the ascending order or descending order, is called sorting. Now, what is the importance of sorting? Sorting is critical basically for tasks like searching. Searching like linear search, binary search. Suppose searching is the process. Suppose we have a array elements and we want to find a single element in the given array elements, and that is called searching with the help of linear search, binary search, etc. Now, sorting algorithms. There are many sorting algorithms like bubble sort, merge sort, quick sort, etc. Now, our topic is what is quick sort? Quick sort, basically it is a divide and conquer algorithm that efficiently sorts the data either in the ascending order or in the descending order. Now, what are the steps that we have to follow while working with the quick sort algorithm? The step number one is we choose a pivot element and rearrange the data accordingly. Means the step number one is we choose a pivot element and the elements that are less than the pivot element will go to the left hand side and the elements that are greater than the pivot element will go to the right hand side. Now, with the help of the example, it will be more clear to you what is quick sort algorithm and what is the process of working with it. Suppose there's a given array elements and the array elements are total number 6 and the elements are 10, 7, 8, 9, 1 and 5. Now what is the first step of solving these type of problems? Initially we choose the last element as the pivot element. Now, when we're choosing the pivot element, the question arises, what is pivot element? The pivot element can be the first element of the array element, or it can be the last element, or any random element you want, right? Basically, we choose first or last element from the given array elements. Now, first we choose the last element over here is 5. The total number of array elements are 10, 7, 8, 9, 1 and 5 and the last element is 5. We choose 5 as the array as the pivot element, right? Now one by one we compare the first element with the pivot element, the second element with the pivot element. In this way we'll sort this type of problems. The number one is 10. We'll compare 10 with the 5. 5 is the pivot element and we'll compare 10 with the 5. Next, 10 is greater than 5 or less than 5. Obviously, it is greater than 5. So, it will go to the right hand side of the pivot element. Now, 7 is greater than 5 or less than 5. 7 is greater than 5. So, it will go towards the right hand side of the pivot element, that is 5. Again, 8 and 9, these elements are always greater than 5. So, we'll put towards the right hand side of the pivot element, that is 5. And the only element, single element 1 is less than the pivot element. So it will go towards the left hand side of the pivot element, that is 5. Now our sorted arrays 1, 5, 8, 9, 7 and 10. It is not sorted completely, but the first step, initial step is completed. Now 1, 5, 8, 9, 7 and 10. Less than the 5, that is 1. It is already sorted and greater than 5, 8, 9, 7, 10. These elements are not sorted. Then the element that is 1 is called the sub-array number 1 because less than the elements, less than pivot elements are called the sub-array number 1 and the greater elements are called the sub-array number 2. Right? Sub-array number 1 that consists only one element, it is already sorted and the sub-array number 2 that is 8, 9, 7 and 10, it is not sorted. So what is the process? We'll continue the process again on the sub-array number 2 only, right? And what is the process? 8, 9, 7, 10. The last element over here is 10. So the pivot element over here is 10. We again compare 8, 9, 7 with the 10 or pivot element. Then what will be the result? 8, 9, 7, 10. Pivot is 10. Now 8, 9, 7, 7 will go towards the left hand side of the pivot element, because these elements are less than 10, and no element go towards the right hand side of the pivot element, because there are only 4 elements and 10 is the largest element, right? Now 8, 9, 7 again, so left hand side 8, 9, 7 and right hand side 0. So again we will sub array number 2 over here is 8, 9 and 7, right? So again we'll continue the process again. Then that is, first we choose a pivot element in between 8, 9 and 7. 7 is the pivot element. So we'll compare 8, 9 with 7. 8, 9 is greater than 7. So it will go towards the right hand side of the 7. So the list will be 7, 8 and 9. Okay. Now the our completely sorted array is 1, 5, 7, 8, 9 and 10. Means in quick sort algorithm, we sort the data elements on the sub-arrays. We work on sub-arrays, right? After that, we'll complete the merge the all the sub-arrays, and this is the complete sorted array list, right? Now it's time complexity. Best case, average case, worst case. We'll discuss about when the pivot divides the array into two equal halves, means into two sub arrays, sub array number 1, sub array number 2. Worst case, suppose we choose the smallest or largest element at the pivot element, then it is already sorted. The elements are already sorted. Now, we'll again is example number 2. Example number 2, there are 4, 3, 1, 2, 5, 9, 7, 10, and 6. There are 9 elements, and among the 9 elements, we'll choose the pivot element. This is number example number 2. We'll again choose the pivot element in between in among the 9 elements, that is 5. 5 is the pivot element. Now we'll compare one by one with the pivot element, and the less than elements go to the left hand side, and right hand side it will greater than elements, right? Now 4, 3, 1, 2 are less than 5, so it will go towards the left hand side. 9, 7, 10, 6 are greater than 5, so it will go towards the right hand side of the pivot element, that is 5. Again, now we got two subarrays. Subarray number 1 that consists 4, 3, 1, 2. And subarray number 2 we consist 9, 7, 10 and 6. Right? Now we'll work on subarrays. We'll again repeat the process. 4, 3, 1, 2. We'll again choose the pivot over here, that is 2. Again compare one by one all the elements. 4 with 2, 3 with 2, 1 with 2. And in subarray number 2, we'll choose the pivot as 6, right? Because last element, 6 is the last element. We'll compare one by one, 9 with 6, 7 with 6, 10 with 6. These all are 9, 7, 10 will go towards the right hand side of 6. In the same way, in subarray number 1 is 4, 3 will go towards the right hand side, and 1 will go towards the left hand side. So again and again we'll repeat the process in this way, and the finally sorted array will 1, 2, 3, 4, 5, 6, 7, 9 and 10. In this way we'll work with the quick sort the arrays using quick sort algorithm. Advantages: it is a divide and conquer algorithm. We all know because it works well for the large data sets. There are number of elements. Suppose there are many elements in the array, then we'll work on with the quick sort algorithm. Okay, done with the quick sort algorithm.